Problem 31. Use the problem below to answer the question that follows. All right, so this is our problem. A red car and a blue car compete in two 100-mile races. That's the first race. That's the second race. In the first race, both cars leave the starting line at the same time. That's right there. When the red car crosses the finish line, the blue car has 10 miles left to go. They drew that right there. Red car crosses the finish line. Blue car has 10 miles left to go. In the second race, both cars start at the same time. But while the blue car begins at the starting line right there, the red car begins 10 miles behind the starting line. Fair enough. Assuming that each car's average speed does not change. That's a big assumption. So I'm assuming from race to race they have the same average speed. How far has the blue car traveled in the second race when the red car reaches the finish line? So the red car reaches the finish line. The blue car has traveled this distance, x. That's what they want us to solve for x. How far has the blue car traveled when the red car finishes the finish line? Now, this statement right here, assuming that each car's average speed, at least in my brain, is a big clue. It tells us that that's important, that their average speed is the same. So from race to race, they don't have, obviously, the same average speed. The red car is faster in either case. So let's say that r is equal to the red's speed. And let's say that blue is equal to blue's speed. Now, in either situation, either drawing, let's say in the first race, they both traveled the same amount of time. The same amount of time it took the red car to go the whole 100 miles, the blue car traveled this distance, which is 90 miles. How did I know 90 miles? Because he has 10 miles left to go in a 100-mile race. So, if we know that distance is equal to, sometimes you say speed times time or rate times time. I'll use speed just because I already used r, is equal to speed times time. That also tells us that time is equal to distance divided by speed. So in the first race, in race 1, the time that the red car took to finish the 100 miles is 100 miles divided by r miles per hour. Miles per hour. Notice the units will cancel out properly. If you divide miles by miles per hour, you're left just with hours. So this is the time it takes for the first car to finish the race. Now, we also know that's the same amount of time it took the blue car to go 90 miles. So that is going to be equal to 90 miles over B, or blue's miles per hour. Right? That's what the first race tells us. Now, what does the second race tell us? The second race, we can do the same logic. Race 2. So, in the time it takes the red car to travel 110 miles, right? He travels the whole 100 miles and he started 10 miles back. So the red car, 110 miles divided by red miles per hour is equal to what? It's equal to x, the distance the blue car travels. It's equal to x miles divided by blue's miles per hour, B miles per hour, just like that. Now, what do we have here? We want to solve for x, and maybe, just maybe, if we can find an expression for r, the ratio between r and b, then maybe we can solve for x. Let me show you what I mean by that. Let me switch colors to make this a little bit less monotonous. So this first, from race 1, we got the information that 100 over r is equal to 90 over b. So if we multiply both, if we cross multiply, we essentially get 100 times b is equal to 90 times r. If we divide both sides by 90, we get 100 over 90. B is equal to r. If you divide both sides by b and you swap the sides, you get r over b is equal to 100 over 90. So we know what the ratio of red speed to blue speed is. It's 100 to 90. Now, can we do the same thing here? Let me do this in red. Well, maybe no, it's red. Okay, so here if we cross multiply, from race 2, we have 110 over r is equal to x over b. If we cross multiply, we get 110b is equal to rx. And then, let's see, if we divide both sides by x, we get 110 over x, b is equal to r. And then if we divide both sides by b, we get 110 over x is equal to r over b. That's the information that the second race gave us. Now, the first race already told us what r over b is equal to. It's equal to 100 over 90. So we can replace r over b, based on the information in the first race, with 100 over 90. Now let's see. So our big takeaway, notice they don't want us to solve for x, they just want us to set up the problem, is 110 over x is equal to 100 over 90. Now let's see which of these choices say that. 110 over x, 110 over x is equal to 100 over 90. That's choice A, just like that. Next problem. All right. Use the diagram below to answer the question that follows. The diagram above is used to describe the relationship between the circumference, right? The circumference is going around the circle, the radius, that's the radius, and the area of a circle. The area, we know what the area is, assuming that the circle is divided into enough sections so that the figure on the right approximates a rectangle. Which of the following relationships is demonstrated? So here they divide it into 6 wedges. Looks like a Trivial Pursuit piece, and they put them all up. But you can imagine if you made the wedges even thinner, if you divided it into 12 wedges, then it would start to look like this. It would look like this if you did it into 12 wedges. And if you did it into 24 wedges, it would start looking more and more like a rectangle that looks something like that. The more you divide the wedges, it looks more and more like that. So let's see what they're trying to show us. So this is r right here. On the wedges, this distance, or actually this distance, is also r, right? That distance is also r. And if the whole thing is obviously the circumference, over here on our kind of approximated rectangle, what's our circumference? Well, our circumference is that plus that plus that plus that plus that plus that. So if we just look at maybe the base of our rectangle, that is one half our circumference, right? That's 1/2 our circumference, because our circumference is these arcs plus this arc, these 3 arcs. So this is just half of them. So the area of the rectangle, this rectangle, which is the same thing as the area of this circle, because all we did is we just kind of cut up the circle and rearranged it into a rectangle, or we approximated a rectangle. The area of the circle or the rectangle is going to be the base, which is equal to 1/2 times the circumference times the height, which is the radius. And, well, lucky for me, that's actually the actual choice. Choice A. Just like that. Actually, this is a fun exercise. Maybe I'll do a whole video explaining why area is 1/2 the radius times the circumference using this example. Because if you divide it into more and more wedges, this is going to look more and more like a rectangle. I'll leave that for you to experiment with. Problem 33. A pretzel company sells pretzels in a cylindrical container with a radius of 10 centimeters and a height of 30. Let me draw it. So cylindrical container, radius is 10 centimeters, and then the height of our container is 30 centimeters, right? It's all centimeters. The company's packaging designers are considering switching to a new cylindrical container with a radius of 20, so it's bigger radius of 20 centimeters, and a height of 15 centimeters. How does the volume of the proposed new container compare to the volume of the old container? So the old container's volume is going to be this area times the height. So it's going to be, so the volume is equal to the area pi r squared. R is 10. R squared is 100. So it's going to be 100 pi. That's the area up here. That's 100 pi. And then we're going to multiply that times the height, times 30 centimeters. And so it's going to be equal to 3,000 pi cubic centimeters. That's our old container. Our new container, what's the area up here? Pi r squared. The area is equal to pi times r squared. R is 20. 20 squared is 400. It's 400. So our volume is equal to 400 pi times 15. And what's 400 times 15? 400 times 15 is what? 6,000. 400 times 10 is 4,000. 400 times 5 is 2,000. Right, it's 6,000. So the volume of our new container is 6,000 pi centimeters or cubic centimeters. So our new container has twice the volume of our old container. So let's see if they say that. Let's see, the volume of the new container is twice the volume of the old container. That is correct. Choice D. Next problem. All right. A fuel tank was approximately 1/8 full. After adding $50 worth of fuel, the tank was 3/4 full. If the fuel costs P dollars per gallon, all right, approximately how many gallons does the tank hold when full? So let's see, we added $50 and it's P dollars per gallon. So 50 divided by P gallons took us from 1/8 to 3/4 full of a tank. So how much did it add? We went from 3/4 of a tank, from 1/8 of a tank to 3/4. So how much did we add? If we just take the difference between the two, we can rewrite 3/4 as 6/8 minus 1/8 equal to 5/8. So we added 5/8 of a tank. Going from 1/8 to 3/4 is adding 5/8 of the tank. So this is equal to 5/8 of a tank. Of a tank of gas, of our fuel tank. Now they're saying approximately how many gallons does the tank hold when full? And it's all in terms of P. So to solve for one tank, we can multiply both sides of this equation times the reciprocal of this, times 8/5. Let's do that. So you multiply 8 over 5 on the left-hand side times 8 over 5 on the right-hand side. And then you're left with, well, I can just cancel. 5's cancel here, 8's cancel here. That's why I did it. So one tank is equal to 8 over 5 times 50 over P gallons. So if we just divide the numerator and denominator by 5, that becomes 10. That becomes 1. 8 times 10 is 80 over P gallons is equal to 1 tank. And that is choice A. Choice A. Next question. A homeowner, let me switch colors. A homeowner is planning to use carpet tiles to cover the floor of a room measuring 9 feet by 10 feet 8 inches. So it's 9 feet by 10 feet 8 inches. Whenever I see that, I don't know, I like to write it as a decimal, or I like to write it just purely as inches. How many inches is this? 10 feet is 120 inches, right? 12 inches per foot. So 120 plus 8. So this is also 128 inches. I'll just write that there. So it's 9 feet by 128 inches. If the carpet tiles are 8 inches wide and 1 foot long, and there are no gaps between the tiles as they're placed on the floor, how many carpet tiles will the homeowner need to cover the floor of the room? So I'm going to place them this way just because I kept this side in foot. So I'm going to use the foot dimension on the foot side. So this is 1 foot by 8 inches, right? That's the dimension of our tile. Let me do it in a different color. It's 1 foot on this side right here, and then 8 inches on that. So clearly we're going to be able to add, we're going to have 9 tiles because we have 9 feet. So we're going to have 9 tiles in this direction. And then how many tiles in this direction? It's 8 inches, and we have a total of 128 inches. So how many times does 8 go into 128? 8 goes into 12 once. 1 times 8 is 8. 48. 8 goes into 48 6 times. So you'll have 16 tiles in that direction. 9 tiles here, and I guess on the width, 16 tiles in the length. So we're going to have 16 times 9 tiles. 6 times 9 is 54. 1 times 9 is 9, plus 5 is 14. So we're going to need 144 tiles. So that's choice C.